Welcome to the Ideal video series on frequently asked questions. This is a series of short videos to explain how to approach common scenarios, model specialized BMPs, or troubleshoot typical issues. Today's video is about modeling and calculating treatment efficiencies when runoff from offsite drainage area travels through your site. In most cases, offsite drainage area can and should be diverted around your site. However, there are times when passing it through your site is unavoidable. In these cases, the way it is handled in Ideal is dependent upon several factors. The first point to make is that Ideal cannot recognize the difference between on-site and off-site drainage area. It is all simply drainage area to the model. If you need to model off-site drainage in your model, use the factors described in this video to learn the best approach. There are two basic considerations for modeling off-site drainage area. The first is whether to model it, and the second is how to find the trapping or loading information you need to demonstrate compliance with the applicable water quality standard. The decision of whether or not to model offsite drainage is dependent on the way your site handles the offsite drainage. If you design a means of bypassing that runoff through or around your site without affecting any BMPs, then you do not need to model the offsite area. If the offsite area will enter a BMP, then it must be modeled because it will affect that BMP's performance. Even if you're not required to treat the offsite runoff based on the water quality standard, you still have to model that flow through your BMP to ensure you're getting accurate trapping results. The decision of how to demonstrate compliance with a water quality standard depends on the standard. No matter what it is always necessary to ensure that offsite drainage area is modeled as a separate watershed area so it can be isolated in the results. If runoff from outside of your site is going through your site's BMP or BMPs, then compliance with water quality goals may require hand calculations from the results. A pre versus post water quality standard is when you're comparing the post-development loading of a constituent to the pre-development loading of that constituent, and usually ensuring there is no net increase. This is the easiest standard in this situation. The first step is to model the same total area in the pre-development model and the post-development model. If you do that, you can still compare the total loading of the constituent at the outlet from the pre-development model to the post-development model without any need to subtract or account for otherwise the offsite loading. The offsite loading won't affect the comparison because it will produce the same load in the pre-development condition as it does in the post-development condition. A trapping efficiency water quality standard requires slightly more thought. This is a standard that states you have to trap a certain percentage of a certain constituent regardless of the pre-developed condition, such as 85% of total suspended sediment. Because this standard requires you to trap a certain percentage of a constituent, you have to assume that the standard only applies to that constituent generated on site. In this case, we're not worried about a comparison to the pre-development site, so you only have to be careful about getting areas correct in the post-development condition. This situation is slightly more complicated when demonstrating compliance, however, because you will find that if you model offsite area, you can no longer use the trapping efficiency calculation Ideal generates automatically. The last row of the Ideal report is the overall trapping efficiency of sediment. If you've modeled your entire site and nothing else, this number is used to demonstrate compliance with a standard like the 85% TSS trapping standard. But if the model contains offsite area, Ideal can't distinguish the percentage of sediment generated on site that was trapped, so you have to ignore this value and do the calculation by hand. Fortunately, it is a simple calculation. The equation is constituent mass trapped in all BMPs divided by total constituent mass generated by all on-site watershed areas. Thank you for using Ideal. As always, if you have questions about Ideal, please contact the StormOps support team at info@stormopssoftware.com. Also, visit our website and follow us on LinkedIn to get the latest news on support and new releases.